Thank you for making time out of your busy schedules this morning to stop by. And we're going to continue on with a brief story that we started over with our friends at Nautel. As we're going to kick off and announce a technology that we're calling Omnia Direct. Omnia Direct is finally something that we kicked off, I should say we started about 15 years ago actually out here at NAB, and that was the concept of being able to connect the output of the audio processor utilizing the audio processor stereo generator and composite signal, and to be able to hand it off to an exciter or a transmitter in a linear digital function. A number of years ago, in order to do this, we had to basically create an ad hoc method of doing it, which had to be dedicated to whatever the digital scheme was done by that specific digital exciter manufacturer. Well, we've been able to make use of an existing standard along with the group from Nautel, and I'm here to talk about, and I'll go through a quick description here, how we're able to take the output of the stereo generator and hand it off to the modulator section of the transmitter utilizing an existing AES link or AES connection and running it at a sampling rate of 192 kilohertz. As by quick example, because if you're wondering, well, you know, why did it take so long, or why are we doing this now, or what are the benefits? Here are a couple of simple diagrams as to how the connection between audio processor and exciter have generally been done in broadcasting all this time. Probably the most common is the audio processor with an analog composite output, and that's the 53 kilohertz, what we call the MPX or composite signal, that's generally connected utilizing a BNC cable from the output of the stereo generator, or if it's an independent stereo generator, into either an analog exciter or a digital exciter that has an analog input, which means in order to do this, we would do all the audio processing numerically or digitally, and then at the output of the stereo generator, we would then have to run it through a high-speed, high-accuracy D to A converter to get it back into analog, and in doing so, obviously, we would want to make sure that there's no overshoots, no added distortions, or anything of that nature. Pass it through the BNC cable, go into the exciter to where now it would have to be resampled, and again, we're utilizing some low-pass filters, all components which can possibly affect the peak control, which has already been tightly done in the audio processor, and possibly add degradation even ever so slightly to the sound of the signal, and then the output in the digital domain would be handed off to the modulator. That's basically been, for broadcasters up to this moment, the common way of connecting, let's say, the output of an Omnia or any other broadcast audio processor into an exciter, be it analog or digital. For those that have wanted to stay all digital, in order to do that, we would have to come out of the audio processor in the digital domain utilizing AES, but in the what we call the left-right or stereo domain, connect into the exciter in AES, and then we're going to rely on the exciter to do the stereo generator, stereo generation function. In most cases, that will work A-OK. But if there's a different output sampling rate here as compared to what's going into the exciter, sample rate converter would need to be applied, and sample rate converters on their own can cause some annoyance to the signal, generate overshoots, possibly affect minimal degradation to the signal, and then we lose some of the modulation efficiency into the transmitter, although we have a full digital path. One of my concerns about this is that this method, I have always felt, has been electrically less efficient than this method, even though there's D to A and A to D here. This is why 15 years ago, I think it was at the 1998 NAB, we showed the ability to do this. And not only was the peak control precise, but we did hear some added improvement a tightness on the low end, and a lack of smearing, if you will, ever so slightly in the high frequency domain. So it's an idea that's been in the back of our minds for a long time. Every so often somebody would reach out to us and say, have you ever done anything about that, digital composite method or what have you? And in and among everything else we've been trying to do with Omnia and our team, that idea, like the single sideband thing that we talked about last year, always has sort of been semi-active on the shelf. Well, bring a long story short, last fall I was at the Madison Broadcasters Show, and I was having a casual chat with my buddies over at Nautel, Chuck Kelly and his gang, and the topic came up. And it's always amazing how the mind will open up once you get a few beers or glasses of wine in you. And we got to talking, and one thing led to another, and we're thinking, and as I'm saying this, I'm thinking, I know of a couple of R&D engineers back in Cleveland that are going to probably have my hide over this, but I tip my hat to Cornelius Gould, Rob Dye, Bill Mohat, Eds McGinsky, Mark Manolio, Matt Klass, and Goran Thomas, the rest of the Omnia R&D team, because they did the heavy lifting to technically make this happen. So now what we're able to do is basically we come out of our stereo generator with precision peak control and whatever utilities we want to add to the multiplex signal, like could be single sideband, and we are electrically in a linear fashion going over AES, and in this case we're coming out of this unit and going into this transmitter. And basically Nautel has said, you give us the signal with proper peak control at this sampling rate, and we're going to give you direct access to the modulator. Well, whatever Omnia 11 over here is doing, this transmitter is going to modulate. Now, what we've heard is that the same as we had 15 years ago, low end is a little tighter, extreme precision on the peak control, the high end is even smoother sounding, and then there's a couple of other benefits to this. We know in broadcasting today, the desire for wide area access of distributing a signal is important, and especially in the international domain. We've had inquiries of people that want to have everything in one package, like what happens here in Omnia 11, and know that they can faithfully have this signal end up at the local transmitter or somewhere, hundreds of miles or hundreds of kilometers away, and be able to linearly hand that off to a transmitter. Any distribution system, and there are some distribution systems, I know in Sweden, as one example, where we can take the AES composite, we call it Omnia Direct, but technically it's MPX over AES, get it into a distribution system of this nature, and then anywhere in their transmission area, they can just plug right into something like this transmitter, and then whatever's done here, this is going to do on the air. So yet again, we're doing our best to push the envelope for the betterment of broadcasting, where, as I mentioned last year, being able to do single sideband on the composite signal, there are benefits for coverage areas that are severely affected with multipath. Now we're able to actually give the broadcaster yet another, everyone's always fighting for that. I know it may sound trite, but that little, that 10th dB is it clarity, is it loudness, is it punch, or what have you. There are benefits to this. And also I will say that the performance of the Nautel transmission products sonically are, they're at the top of the list. So now we're able to marry something like Omnia 11 with the NV series transmitters done by Nautel, and now you dial into whatever this frequency is, you're going to get that wallop. Sort of like 30 years ago when somebody went from worst to first, and there was a top of the hour idea that said lock it in and rip the knob off at Z100. That's what you're going to have with something of this nature. So that's the main thing that we wanted to talk about here this morning. And if anyone wishes to have any more detail about what I'm talking about, I believe our marketing gang, see Angie, we've got, I think we have some stuff on some USB sticks. We're happy to share those with you. And if anyone has any questions about the technology, I'm happy to answer them. And not only, are we showing it running, but you could actually hear it. We have some test equipment set up. We can, take a look at the P control and look at the spectrum and things of that nature. And we'd be happy to answer any questions or give any demos that anyone might have. Once again, thank you very much for your time and being able to come and share some of your precious time with us. And I wish all of you the best of success here in Las Vegas this week. Thank you.